This video shows how to read out pin number 2 of an I/O link port in addition to the data of your connected I/O link sensor in an EtherCAT network. This means that I/O link data and an additional binary signal, such as from a limit switch or proximity sensor, can be read in via a so-called A port of an I/O link master. Let's first take a look at the hardware. Regardless of which EtherCAT I/O link master is used, the information of the additional binary signal can always be read out in the same way. The I/O link master AL1332 is connected to an Omron NX1P2 PLC with EtherCAT interface. As shown, two sensors are connected to port 2 of the I/O link master. A TN2105 temperature sensor with I/O link interface and a IFT245 inductive proximity switch for the binary signal are connected to port 2 of the AL1332 master using a EBC113Y splitter. We go to the IFM homepage and navigate to the AL1332 master online datasheet. Under wiring, you will see the pin assignment of the individual ports. All I/O link ports are so-called A ports. A suitable Y splitter is used to read in an additional binary signal. Both sensors are supplied via pins 1 and 3 of the I/O link port. Pin 4 of the I/O link temperature sensor is connected to pin 4 of the A port of the I/O link master. In addition, the switching signal of the inductive sensor, which is also output via pin 4, is connected to pin 2 of the same port. Pin 5 is not used on an I/O link A port. Let's have a look at this setup in the Sysmax Studio programming software from Omron. As already mentioned, this video shows how to read out pin number 2 of an I/O link port. If you have further questions about communication settings, the data structure of an I/O link sensor, or the necessary programming steps, please watch the corresponding I/O link integration video. We go back to the IFM homepage and select the download area for the master. Open the operating instructions and search for the term pin 2 using the search function. We quickly find the information that the additional digital input is stored in the PQI byte with the index F101 of the corresponding port. The mapping of the port qualifier information byte shows us that the status of pin 2 is mapped to bit 1. We find the port qualifier information with index F101 in the I/O map of our master. Currently, this information is displayed in unsigned short integer format. However, in this format, we cannot determine the status of pin 2 of I/O link port 2, to which our sensors are connected. If the format is changed to binary, the status of bit 1 can be read. The temperature value of the I/O link sensor, with index 6000, is also displayed in its raw format. In order not to display both the temperature and the switching signal in raw format, we convert the values and display them clearly in a watch table. We go online and check the incoming data. First, we see that the temperature value displayed in the software is the same as the value displayed by the sensor. At the same time, the inductive sensor that sends the switching signal to pin 2 is damped, and the binary signal is also displayed accordingly in the software. Thank you for joining us.